All right, 5C, one more limacon for us to graph before we move on to Rose curves. Um, R equals 2 minus 2 cos theta. And we're going to do the same thing. We're going to graph the Cartesian graph first. And again, since we have no modifier on theta there, we're just going to get a normal 2 pi period. So we can split this up as we usually do. And then we can recognize that that 2 is going to shift everything up 2. So that is where my axis of symmetry will be. And this 2 is going to, again, be my amplitude. So it will go up 2, which will put me at 4. Now we'll go down 2, which will put me on the x-axis, 0, the horizontal axis, I should say. Because again, we're talking about theta and I, theta and r. Now, where you need to be careful is that you need to recognize that we are subtracting 2 cosine theta, which means we're dealing with a negative cosine graph, which means we're dealing with the opposite of a cosine graph, which means instead of starting at its maximum value, it will start at its minimum value. And then it's going to run through its cycle like it normally would. Easy to miss that, but it will change some things. So let's sketch this in. Something like that. Almost looks like a little ghost. Boo. Okay, whatever. Let's now go on from here. So, first point now is actually at the pole. So we're going to hit that spot right there. Second key point, when pi over 2 is our theta value, we have a radius of 2. And so we're going to get this value right there. But what about in the middle, between there? What happens at pi over 4? Well, again, we're going to plug into our equation. R equals 2 minus 2 times the cosine of pi over 4. So again, R equals 2 minus 2 times root 2 over 2. Look, those 2's cancel. And so we have R equals 2 minus the square root of square root of 2 is a good number to know. It's roughly 1.4. So we have essentially 2 minus 1.4, which means we're dealing roughly with 0.6. And you should get to the same spot if you plug in the actual cosine and theta values. You should get about 0.6. It's actually a little less than that, but we're not really able to graph that accurately anyways. So what are we doing with this? Well, theta was pi over 4, and the radius was about 0.6, so a little over half. So we're getting a point about right there. I'm on the pi over 4 line, and I'm about 0.6, so I'm about halfway up to that first circle. So this is starting by curving out like that. All right, what next? Well, I can go back to my Cartesian graph here, and I can see that when I hit pi, my radius is 4. So when I hit pi, I'm at 1, 2, 3, 4, right there. But again, let's make this more accurate. Let's figure out where I am at 3 pi over 4. So where am I up at this point right there? Well, again, let's just plug some stuff in. R equals 2 minus 2 cosine of 3 pi over 4. Now at 3 pi over 4, what's the value of cosine there? Well, it is negative root 2 over 2, so R equals 2 minus 2 times negative root 2 over 2. So think about what happens. My negatives cancel, my 2's cancel, and I get 2 plus root 2. So R is going to be roughly 2 plus 1.4, which means it is roughly 3.4. And that was for the theta value of 3 pi over 4. I'm roughly 3.4. So 1, 2, 3.4 is about there. And I can continue this curve out and down like that. So again, recognize now I'm at pi, which means I'm halfway through my cycle. And this graph has perfect symmetry with respect to theta equals pi right there. So it's going to run back through this cycle. Key point here at 3 pi over 2, radius is 2. So I'm getting that mirrored point right there. Similarly, if I look at 5 pi over 4 right there. We already know that R value from last time is 3.4, and so I can plop that on here as well, 3.4 right about there. Continuing through, I know I'm going to end where I started, back at the pole, and 7 pi over 4 right there is going to have the same y value as it did at pi over 4, which was 0.6. And so I'm going to get that 0.6 right there. Again, it's all perfect symmetry, and this is going to curve around and back in. I'm going to have a sharp little point there, and this is a cardioid, which is another type of a lemmathone. This happens specifically when A over B equals 1, when your A value and your B value are the same. Notice the 2 and the 2 there gave us this cardioid. Done.